This question asks us to identify the natural and forcing frequencies, omega naught and omega, and determine whether resonance occurs. If resonance does not occur, but omega naught is approximately equal to omega, we want to find the amplitude and frequency of the beats. We're given this second order equation to work off of. Well, it's pretty easy to identify the forcing frequency. It is the coefficient of t inside that cosine, so omega equals 2. And the textbook gives me an equation for omega naught, and it is the square root of k over m, which I can identify from this equation to be 11 and 3 respectively. So I'm looking at the square root of 11/3. I put that in my calculator earlier, and it is 1.915. So does resonance occur? No. Omega naught doesn't equal omega. It is pretty close though. So let's try to find the amplitude and frequency of the beats. The textbook gives you an equation that's going to help us do that. And it is the general formula for x of t, that motion we want to find. And it is a long one, but it is 2f naught over m over omega naught squared minus omega squared times sine of quantity omega naught minus omega times t all over 2 times the sine of omega naught plus omega times t over 2. And this portion right here is my amplitude. So to find the amplitude, I'm going to focus on this portion here. And I can identify all of these things from the given equation. So f naught is going to be 2, because that's the coefficient of that cosine there. So this is going to be 4 over mass I can identify as 3 over omega naught squared minus omega squared. Now that's something you would want to do in your calculator. I'm just going to write it. I did most of this in my calculator earlier, but I'm just going to write it there for now. And then I can go ahead and plug this in. I'm going to get 1.915 minus 2 all over 2, which is going to be negative 0.425. .0425, excuse me. And this coefficient of t right here is going to give me the beats. So I can really ignore this portion. So this is a negative, sorry. So when I work this out, I'm going to get negative 4.0067. So I have negative 4.0067 sine of negative 0.0425 t. And right now my amplitude and frequency are both negative, but we know that can't really happen. So we're going to take the advantage of the function of the fact that sine is an odd function, which means that the sine of negative x equals the negative sine of x. So I'm going to swap this negative here for a negative on the outside, which makes this positive. So now I can identify amplitude and frequency. My amplitude is going to be approximately 4. And my frequency is going to be 0.0425. And that finishes off this question.